Okay. So lastly, if you guys remember from chapter 1, according to the nebular theory and the early formation of our planet, the Earth is basically layered and contains the elements that it does due to these things, due to this formation. So these elements that each layer contains are usually spread the way they are based on the layering patterns, the different densities that they also have within the Earth. Usually how the Earth also radiates back some of the heat comes from the initial formation of it. And also things like the pressure and the temperature increase with depth have a lot to do with the formation and with the nebular theory of overall formation of our solar system. Overall, it is through seismic waves that we know the structure of the Earth's interior. And we know that the Earth is not homogeneous. If the Earth was homogeneous indeed, meaning that it would have the same material throughout the whole Earth, then the seismic waves would travel nearly at the same rate throughout the Earth's interior without any reflection, any refraction, or any diffraction. But we do see some seismic waves go through different media. So we do see them go through solid, liquid, and gaseous phases. And we see that these also have different densities as they travel through. So we see them travel at different rates due to the different physical natures. So overall, the Earth must not be homogeneous, but rather be heterogeneous and be relatively layered. And so we see those layers within the Earth's interior thanks to seismic waves and how they have been received at seismograms and how they have been interpreted. So based on seismogram records, the depth of said layer boundaries can be determined and have been determined, in fact, to give us what today's physical subclassification of the Earth's interior is, the one that I had shown you initially on chapter 1, where you have this subdivision of inner core, outer core, lower mantle, then you have the transition zone, the upper mantle, which is composed of, again, that transition zone, the asthenosphere, lithosphere, and then you have the within the lithosphere, you have the crust itself. Okay, so let's go ahead and watch this short video that I have for you. It shows, okay, so again, it's going to show you how the waves are going to behave at the surface, how they're going to behave at depth, and how they are expressed in the receiving seismograms. So all of these waves were from the, as this video said a little earlier, recorded from the tsunami that happened in 2004, the tsunami that occurred due to the magnitude 9.2 earthquake that ended up causing the tsunami in Sumatra. So overall, this is a pretty great video in showing you how those waves behave. I encourage you to pause it every now and then so you can keep track of the different wave types and how they are expressed, again, at the surface, at depth, and as they are recorded in the seismograms that are receiving those wave arrivals, okay? So let's check that out real fast, and then I'll let you pause it on your own if you need to as well. So that's the earthquake. Then you're seeing the P waves travel faster than S waves and surface waves. See, the P waves go through the outer core, but the S waves don't. They get reflected. However, the P waves do get refracted down here in the outer core and travel differently in the outer and inner core. So it gets a little bit more complex the further you go within the video, but let's check the seismograms. So you have it at 5 different locations. So let's check how they behave. Okay, so it hit this location, the Coco's location over here. So you saw the first P wave arrive to it, and now you're going to soon see the first S wave arrive to it. And then pay attention to how fast the P wave is going to arrive to this Kyrgyzstan station. Alright, so the P wave arrived to the Kyrgyzstan station a little bit before the S wave arrived to the Coco station. And again, I encourage you to do what I'm doing throughout the whole video, just so you see what the relationship is between travel time, between travel at depth, between the different curves and the angles at which they travel, meaning the rates at which they travel, and the medium through which they can travel, and whatnot. Okay. So again, with that awesome video, I encourage you again to watch it, pause it, rewatch it. And with that, we are done with chapter 9. I didn't go in as much depth as I could have for this last section of chapter 9, but we saw that all in chapter 1, so I figured if I covered it again, it would just be for the purpose of illustrating how seismic waves are already a cause for subdividing the different layers within the Earth's interior. So you can review it on your own in the book if you choose to. I won't quiz you on it further than what I have said here in lecture. Okay, so as always, let me know if you have any further questions, and I hope you have enjoyed this lecture.